Hi everyone, I'm Marcus Voss from AXO, and today I'm going to tell you what the concept of accelerated software engineering is, what role knowledge modules we call best practices play in it, and what it is that belongs to the core, to the fundamentals, to a foundation for such a particularly productive software engineering. We remember, in the previous video introducing software engineering, we showed how the discipline evolved into what we would now call modern software engineering. Iterative and agile software development, the interlinking of development processes with operations and also with the business, and the approach of continuous value stream-oriented development of digital products. On this basis, we define the concept of accelerated software engineering, that is, software engineering with increased productivity, and a special focus on both effectiveness and efficiency in industrial practice. Modern software engineering contains a huge pool of different practices, that is, applications of methods, techniques, and tools. Accelerated software engineering now means knowing these practices, selecting them according to the situation, and applying them in a targeted manner with the goal of optimizing the efficiency and effectiveness of the software project or product development in order to be able to act in a particularly productive and thus competitive manner in industrial practice. Those practices which proved themselves useful several times regarding effectiveness and efficiency in the context of such an accelerated software engineering, that is, in industrial practice, we aggregate them as knowledge modules and call these the practices of an accelerated software engineering, or in short, best practices. To structure this knowledge and to sort the best practices into a comprehensible structure, we define 7 so-called domains of our knowledge. Together, this results in a structuring framework. We will start again with the core development processes, already known from the video on software engineering, because, as I said, these have proven to be very stable over all the years of evolution of the discipline. It should be emphasized once again that modern software engineering with iterative and agile development is not about these core processes being project phases that run one after the other in a project, but about knowledge areas or large task areas in which the many practices can be organized. For our structure or framework, we call the first domain not only analysis but requirements and analysis. Also to note that we can mentally sort in the creative core processes of idea generation or ideation with which requirements can be created or formulated as such in the first place. The actual analysis is then based on this output. We call the second domain not only design but architecture and design. We do this in particular in order to adequately take into account the importance of the subdiscipline of software architecture and the best practices to be sorted in here. Implementation remains implementation. That is, the domain includes all best practices for the actual coding, including the associated fine design of the code. Integration and test, however, we reduce only to test and the associated best practices. Because integration is nowadays part of automation, keyword CI/CD. And we can now define another domain with infrastructure and operations, in which all best practices for the CI/CD, but also more generally for DevOps, can be sorted with the best practices, also for operations and for modern programming of infrastructure. Furthermore, we dedicate a separate domain to the topic of project management and the associated best practices. And additionally, we define a 7th domain in our framework for all those best practices that are cross-cutting, that deal with aspects of the general strategy of the approach. Starting with this process strategy, we number the domains from 1 to 7. This is the best way to look at the many best practices if you want to familiarize yourself with the entire knowledge, as in a course or training. This structuring in terms of domains can also be mapped very well to the so-called Software Development Lifecycle, SDLC for short, which is used today in many basic training courses or in lectures at universities to structure the discipline. The contents or best practices of the process strategy can be understood as an upstream introduction to the life cycle, and then it continues as expected with the domains to the classical core processes: requirements and analysis, architecture and design, implementation, test, and then, with a slightly different focus in terms of DevOps, the domain infrastructure and operations, and shown here in the inner circle because it affects all other domains, project management. The foundation comprises around 80 knowledge modules or best practices that can be assigned here. There are best practices for the following task areas within the respective domains. The first step in the process strategy is to define the basic strategy or approach. What does effectiveness and efficiency actually mean? What does agile mean? And what general process recommendations are there for agile software projects or the agile development of digital products? Then the so-called project context with all the individual influencing factors plays an essential role. What are these? And what effects do they have on my process strategy? Also important is defining or selecting the method to be used for managing the project. Next, of course, at the very beginning, we have to understand the content of our project and develop an understanding of it. Which practices have proven to be successful, and how can I define the scope of my project? Then, how does the commercial side look like, or what is important here? What types of contracts are there, etc.? And finally, what can or should be clarified in advance regarding the cooperation of the people in my team? How do teams develop, and what form of role play makes sense? Then requirements and analysis. What best practices are there to understand the users of the planned solution in the first place and to communicate with them in a targeted manner? Which practices help me to understand the requirements? How do I manage these requirements and how do I capture them? For example, how do I write good user stories, etc.? Then, how do I get from there to a functional specification of the solution? What practices do we have at our disposal? And what role do things like OOA, OOD, or the UML still play today? And finally, how do I ensure user-friendliness and thus acceptance at an early stage? And which practices of optimizing user experience can be recommended? Third is architecture and design. What is actually to be done here? What is architecture in the first place? What constitutes the discipline of architecture? And what is the role of an architect? In how far and with which practices does the architect give orientation? What is a good architectural vision? Then, how does one consider the requirements relevant for the architecture of the solution? What are these anyway? And why are they primarily non-functional requirements? And in the core, of course, how does one actually design the architecture of the solution? What role does domain-driven design play in this? What are common and especially today's current reference architectures or architecture patterns? And what constitutes the currently much discussed ones such as microservices, event-driven architectures, or cloud-native architectures? Then there is also how architecture is best documented and communicated, what practices are available for testing and evaluating architecture, and what are the most important risks in this area and how are they dealt with. Then we move on to the topic of implementation. What constitutes this discipline today? What is software craftsmanship and what does clean code mean? How do I create a good, fine design for my code? What are, for example, solid principles? Or how do I work effectively with design patterns? What practices are there to ensure code quality, good documentation of code, and also, if necessary, how do I evaluate the quality of existing code? For example, if I want to take over existing code for maintenance or modernization. Concerning tests, there are best practices on what approach or strategy is actually appropriate here. How do I plan tests? How many of them, at which levels and in which mode? Keyword test pyramid. Which best practices are there for manual testing? Which for automated testing? And what has proven effective for documentation and evaluation, as well as for ensuring appropriate test quality. In infrastructure and operations, the first thing to be discussed is what is actually coming into focus, with extending the focus to the operational processes and what DevOps is all about. Nowadays, not only software, but also infrastructure is programmed. Keyword infrastructure as code. How does that work, and what are the best practices here? Then, of course, the topic of automating the processes of integration, testing, and deployment, that is, practices for CI/CD. And finally, what does the operation actually include and what has proven useful here? Plus, if applicable, how can you efficiently provide the best environment for the entire development? And finally, the topic of project management. What is that? What does project management mean in general and agile project management in particular? What tasks are all associated with it? Then, quite clearly, how do I estimate, plan, and calculate projects? How do I monitor them appropriately? Keyword controlling. What best practices are there for controlling the scope? What has proven to be successful in risk management? And how do I work with the stakeholders of a project? And finally, of course, the topic of communication and leadership. As you can see, a large bouquet of tasks and issues that are all relevant for effective and efficient modern software engineering. And if we know and can do all this, with this foundation, we have everything to act successfully in our software project in industrial practice. So much for the overview. So we now know what modern software engineering is and how it has evolved. We know what we mean by accelerated software engineering, what role knowledge module or best practices play, and that a set of somewhat like 80 of these modules make up what we call the foundation of an accelerated software engineering, which we're going to teach in the following. And in the next video, we'll jump in with the first of these knowledge modules, the best practice on efficiency and effectiveness. Until then.